All right, so when looking at an exponential function, there's always going to be a base and an exponent, and it is important that we can recognize and name both of those parts of an exponential term. That's going to be directly related to the next part of this unit, which deals with the inverse of exponentials, which are log functions. Okay, so b is the base, x is the exponent. Um, I feel like the exponent part should be pretty obvious. Base, maybe you had some other answers there, but do want us referring to that part as the base. When b is greater than 1, we're going to describe that function as increasing. Okay, and an increasing exponential is going to have this shape, whereas x increases, y is also increasing. But then when the base is between 0 and 1, so usually a fraction or a decimal, we're going to describe that as decreasing. Right, then down to the transformations. Again, these transformations are not new. Up in any given function. So whenever we have this value at the end or after the function operation is the language I described first semester when we did this. So function operation being the exponent part. So after we apply the exponent, that value that's added or subtracted is our vertical shift. When it's positive, we're shifting. This is PF is for parent function. So we're shifting the parent function up by C units. When it's negative C, we're shifting the parent function down by C units. And so the next two transformations are the horizontal shifts, and that's when we're adding or subtracting the values onto the x directly, right? When it's affecting the x coordinate, it's like the opposite operation for what we see. So when it's plus C, we're actually shifting it left by C units, and that's again the parent function. And when it's negative C, we're shifting the parent function right by C units. As we start to add in negatives, so either multiplying the entire function by -1 or the x by -1, those are the reflections. We don't see a lot of reflections with exponential graphs, so we won't have to deal with that a whole lot. But when it's in front of the function operation, and again, parentheses would be important here. This technically is like a negative and then parentheses b to the power of x. That's multiplying all the y values by -1, which is how it reflects across the x-axis. So the y values are going from positive to negative and vice versa. The next one is a reflection across the y-axis. We could actually take this function and just change the base. In fact, that is equivalent to 1 over b to the power of x. So just using some of the exponent properties there. We have a negative exponent. And the last two are your vertical stretches and compressions, and horizontal stretch or compression. So the main thing I want us to remember here is that for a vertical compression, so when it happens after we apply the function operation, if that value is greater than 1, we're vertically stretching it. If it's between 0 and 1, we're vertically compressing it. When that value is being multiplied to the x, it's the exact opposite. So when C is greater than 1, it's a compression. Between 0 and 1, it's a stretch. Okay, and again, we're not going to really see this horizontal stretch or compression, but just want to remind us about it. All right, so the way that we're going to go about graphing these exponential functions is slightly different than kind of what we were doing first semester. We are going to identify the parent function, and then we're going to apply the transformations to the parent function directly on the graph. So every graph that we come up with is going to have the parent function and then the transformed function on it, all on one. So sometimes we might have 2 graphs in one. Sometimes we might have 3 all in the same coordinate grid. I'll give you all a here. Okay, so when we are asked to graph an exponential function, or just when we see an exponential function, I do want us to think about what the parent function is, and it's going to be different for a lot of different exponentials. It always depends on what the base is. So when I see 2 to the power of x minus 1 minus 3, this parent function is just the same base and then to the power of just x. So let's make a note that the parent function here and I'm going to call it g of x just as something different, is 2 to the power of x. And so when we're graphing exponentials, we're going to actually start by graphing the parent function. And to do that, we're going to make a table of values of x's and then plug those x's in to find y. And then we'll go ahead and apply the transformations to that parent function directly. So right now I'm going to make a table of x values. And then to get the y's, we've got to plug x into 2 to the power of x. And we're always going to use the same x values. We'll use negative 2 to 2. If we can add in another value that fits on this graph, we will. And so when I have 2 to the power of negative 2, that flips the base. So it makes the base 1/2, and it's really 1/2 squared, which is 1/4. So into the negative 1 is just 1/2. 2 to the power of 0 is 1. 2 squared is 2. 2 squared is 4. And we can go ahead and add in another value that'll fit on this graph. 2 cubed, which is 8. So we'll go ahead and plot all these points. Negative 2 1/4, negative 1 1/2, 0 1, 1 2, 2 4, and 3 8. And so when you are graphing the parent functions on or exponential functions on your own, I do want to see that parent function on the graph. And the reason being is because when we go to graph, we're actually working on graphing f of x here. All we need to do is take this parent function and apply the two transformations that we see. So this x minus 1 is going to shift everything right 1. This minus 3 is going to shift everything down 3. And so that's a really easy thing to do. I can just go to the points. I can go right 1 and down 1, 2, 3. Right 1, down 1, 2, 3. Right 1, down 1, 2, 3. Right 1, down 1, 2, 3. 1, 2, 3. And right 1, down 1, 2, 3. And this in purple is what we're ultimately trying to get to. This is the graph of what we're trying to come up with of f of x. And I'll just go ahead and label that on here. Now, one thing that we'll talk about when we come in next time is that exponential functions, we can see that it's getting pretty horizontal here. Okay, and it's approaching a value, which is a horizontal asymptote. So we are going to fill in the horizontal asymptote for all of the functions that we're trying to graph. Next time, we'll talk about why that horizontal asymptote exists and how we can look at an equation and know where that horizontal asymptote is right from the start. Right, that was short, quick day.